project Cerberus. Cerberus is a self-driving autonomous car that is controlled by voice recognition and by image recognition. Cerberus has the ability to detect several objects, which we have trained three different ones, which is a backpack, people, and bottles. It can avoid obstacles and it can change directions once it finds an obstacle by backing up and turning to the right or left depending which side has no obstacles in it. Following, we're gonna show you how we made it happen.
This is the system of our car. As you can see, we have an Arduino in the top. We have our PCB in the bottom, which integrates Arduino motors, sensors, and batteries. We have three sensors in the front, ultrasonic sensors. We also have a voice recognition module connected to the Arduino with a receiver wireless mic. We also have our Jetson microcomputer and our batteries, which are supplying 7.4 volts. From the top view of our car, we have our two antennas which control the Wi-Fi. And we also have our camera, which does the image recognition. And now from the bottom of our car, we can see we have two motors connected to wheels. And we also have a wheel in the front that rotates 360 for better movement. And we put two motors because it's easy for us to code and also it's more cheaper.
All right, Cerberus. In this part, we have trained the robot to pick up on different objects. One of these objects is the backpack. So right now you're seeing that the robot is trying to avoid the obstacle of the wall. It's gonna reroute and keep going forward. As you can see, it keeps going and there it detects the backpack. However, it also detects a person in the camera and it has a high confidence level on the person as well. So once Ryan moves out of the way, the robot's gonna pick up on the backpack and it's going to stop. Cerberus. Oh no, I'm on the way. Here we can see that we have a Coke bottle that has been trained. It has an 80% and higher confidence level, up to 89%, and it takes less than 7 seconds to detect the item and to come to a full stop. In this part, it takes exactly 7 seconds to detect the object once it's placed down by Ryan.
Cerberus. Go. Stop. Go. Stop. Left. Left. Go.
For this sensors test, we measured a few things. First, we determined the accuracy of the sensors when reporting distance readings. As we can observe in the monitor, the readings from each sensor pointing to a fixed object are all different. Taking a sample of each sensor's readings, we determined that there was a margin of error of approximately 2.5 centimeters that needed to be considered when calibrating the car wheels. After that, we changed the proximity of the obstacles to the sensor to gather short distance readings, and then we proceeded to measure long distance readings. We noticed that when the distance was more than 500 centimeters, the readings show 0. This is important to keep in mind because if there are no obstacles, we cannot consider 0 as a real distance because it will make the car stop for having a close proximity to the object. Instead, we needed to treat it as a long distance or similar distance to the other sensors' readings. If the 3 sensors show 0, the default distance is 30 inches, causing only the car to slow down. The following test was created to study the behavior of the wheels and the sensors. When the sensors identify an object, they measure the distance and report it to the monitor. If the distance between the sensors and the obstacle is more than 48 inches, the wheels move forward at the chosen speed. If the distance is between 12 inches and 48 inches, the wheels rotate at a slower speed, as we can see in the results monitor. Once the distance between the object and the sensor is less than 12 inches, the motors stop.
Okay, so for this part of the presentation, we finally managed to link our JSON Nano with our Arduino. What we're doing here is once the camera is able to see an object, in this case, this bottle, then the wheels should stop working and the car should come to a complete stop. So we're going to demonstrate right now how it's working, how it's voice activated, and what is partially on the screen. Okay, we're connecting right now. And there he goes. So now the code is being flashed. And right, you can see here we have the camera. You should open the camera soon. So you can see right there. So he's detecting a person right now. And then here, Ryan's gonna say the keyword.
Cerberus.
You can see here, in his little push, since it's not in the floor, it's not gonna work properly. It has to detect, and here, as you can see here, it goes really fast when he's pointing towards nothing. However, if I get it closer to something, it's gonna get the speed really low, and if something comes, he's gonna back up. Something goes up, yeah, he's gonna back up and change directions. All right, so right now we're gonna point at the bottle and see how it works.
Cerberus.
And the wheel stopped. Amazing. First time it does. Stops well. It detects the bottle and keeps passing. It's not crashing. It's good. We're gonna point at the bottle. And the wheels stop. As you can see, we pointed at the bottle. Here we have a message confirming that we did it.